All right, here's your support for the AP Classroom assignment for Unit 6. You're given a table of values, and it says, and this is a rate table of values. A tank contains 50 liters of oil at T equals 4 hours. Oil is being pumped into that's going to be important. Oil is being pumped into a tank at this rate that you see above. So that's oil, the rate of the oil being pumped into the tank. Where R at T is measured in liters per hour and T is measured in hours. Selected values of the rate is there, so it's continuous and just selected values of the rate are there. Use a right Riemann sum with 3 subdivisions and data from the table. What is the approximate number of liters of oil that are in the tank at T equals 15 hours? So let's break it down. Step 1 is, how much oil is there right now in the tank before 4 hours? So we're going to start with that number. Next, if you have a rate and you want to know how much oil is being there, you have to integrate the rate, and that will give you the liters. So I'm integrating from 4 to 15, and I'm integrating that rate. Now, how I'm going to integrate that rate to find the number of liters of oil added to 50 that will give me the answer is I'm going to use a right Riemann sum. Now, 3 subintervals, the width then, you would take the top, subtract the bottom, and you would divide it by 3 subintervals. That will give you the width of each one. Now, that is not a nice number. It doesn't matter. The calculator doesn't care. So when you think of the setup, the common width that you have so we're using the 3 intervals at the table. So it's not a common width. I'm sorry. So we're not even going to do this because we're going to use these intervals that are given in the table. So the first width goes 4 to 7, and that's 3. And then a right Riemann sum means use the right value for the height. And again, a right Riemann sum, you would use the width 7 to 12 is 5. And then the right Riemann sum, you'd use 5.9. So do the last one. What's the width? And then use 5.6 for the height. So do the last part. And then put all this in your calculator and then find the answer. Number 2. Press pause, obviously. Then do number 2. The area of the region enclosed by these graphs is what? So I got to graph these. You can use Desmos or your calculator. Can you graph these? So 1 is y equals x. That one's simple. And then the second one, x squared subtract 3x plus 3. It's not factorable. So to get a sense of what this graph is, that negative 3x means it's been shifted to the right. But what I am going to do is, before I graph that parabola that folds up, I'm going to take the 2 equations and make them equal to each other to find the limits, but that also will give me 2 points. So we have x squared minus, 3x plus 3, make them equal to each other and solve it. So subtract x, factor it, so that's negative 3 and negative 1. So these then are the limits, right, when you go top, subtract bottom. So positive 3, so that means because y equals x is also on the line, that 3 will give you the 0.33, 1 will give you the 0.11. So can you find 3, 3 and 1, 1? And then you can draw your parabola. So get a sense of it. It's just a sketch. 1, 1 and 3, 3, it folds up. I want to know top, subtract bottom, and my limits. So I'm going to integrate. And my limits go from 1 to 3. And then what's on top? Subtract what's on the bottom. So you plug in what's on top, what's on the bottom, and then you can integrate it. And yes, you can use your calculator to integrate that. And then, oh, where's the second page? One of these answers will match. So make sure you take a picture of your work, right, that we're doing together here. Number 3, what is the average value for y for the part of the curve that in the first quadrant only? So I need a sketch of it to know what the first quadrant looks like, and then I can set it up. So first I'm going to graph this. So I'm going to actually factor out an x. Those are my intercepts. So when I sketch this, I have an intercept at 3 and at 0. And I know it's negative x squared, so I know it's going to fold down, kind of like that. I actually don't care about the vertex. I just sketch it because I want to know the first quadrant, which is up here in the top right. It's this area. What's the average value of that? How do I find average value? So average value is an integration question, and I'm going to integrate from 0 to 3, and I'm going to integrate the function. And then I divide to find the average value. I divide that answer by the difference of the bounds, and then find the answer that matches. Number 4. Oh, it's right here. Number 4, what is the average value, same question, average value of this over that interval? So it's all given for you. You integrate. What am I going to integrate from? Can you put in the lower limit to the upper limit? What's the function? And then you divide by the difference. All right, you set it up. So put the lower limit, the upper limit, they're right here. Put in the function, dt, and then divide by the difference of the bounds, and then do all the calculating. And then one of these answers on the next page will be it. Number 5. In number 5, you see a graph of the function f from 0 to 3, which has the least value. Oh, I got to look on the next page for the least value. So let me just look at some options here. So if you integrate it, if you do a left Riemann sum, a right Riemann sum, a midpoint Riemann sum, or a trapezoidal sum, which one will be the least less accurate in terms of, I'm looking for the under, the real under. So what am I looking for? It's concave down. So if you actually find it, it's the actual area under the curve. If you do a right Riemann sum of 4 intervals, again, we're going from 1 to 3. So let's say, so that's here and here. So what would happen if I do a left Riemann sum? That's a left Riemann sum. What would happen if I did a right Riemann sum? Can you see the difference? So a left Riemann sum, a right Riemann sum, a midpoint would be the middle between them, and a trapezoid would hug the curve almost exactly. So which one is going to give me the least value? Is it the left Riemann sum, the right Riemann sum, a midpoint, trapezoid, or the actual one? Which one will give you the least, the smallest answer? So you're looking for the biggest underestimate when you draw it in. When it's concave down, the right Riemann sum is under it. The left is an overestimate. All right, I pretty well gave you the answer. 6. At t equals 0, a particle starts at rest and moves along a line in such a way that its acceleration is 24, let's see if I can read that, t squared. And it says, how many feet does the particle move during the first 2 seconds? So to understand that, the first thing I'm going to do is find velocity by integrating acceleration. I need the velocity. So let's integrate that. So that means you add 1 to the exponent and divide. It's probably helpful to simplify it because it's in the middle of the question. Now, what do I do with velocity to know how far the particle moved? That's like total distance. And so to find that, oh, and it's plus c, isn't it? Now, the good news here is when t equals 0, the particle is at rest, which means when it's 0, the position is 0, or it's not moving at 0, so that when you plug this in, this is what it means. So when you plug in 0 for t, in other words, if you solve for c, c is 0. So when we plug it all in, that is the velocity, plugging in what's given. And then to find the total distance it moved over the first 2 seconds, that would be integrating from 0 to 2. And I would use my calculator. And it's the absolute value, because I want the total distance it moved over 2 seconds. So we're going to go 0 to 2, absolute value of that. It actually, the absolute value and no absolute value will give you the same answer, just so you know. Because it's from 0 to 2, it's just positive velocity. If it was negative, it'd be different. So put that in. You don't need the bars. It'll give you the same answer. And then look for the answer. Number 7, let f be that function, 9 to the x. If 4 subdivisions of equal length are used, what is the value of a right Riemann sum? 4 equal lengths. So n equals 4. The width, you take the top, subtract the bottom, divide by how many. You decide what that number is. The formula for this then is that number, the width, so that number you put in for the width, and then a right Riemann sum, you have to think of the interval. So if I'm going to go from 0 to 2, you're counting by that number, the width. So go that width and then plug that number in for x. So I'll give you a hint. The first right Riemann sum is 1/2. So it's 9 to the 1/2. The next one is positive 1. And see if you can do each right Riemann sum. You need 4 of them. And then put all of that in your calculator and then get your answer. Number 8. In number 8, you have a derivative and integration. They undo each other. I want you to substitute in, don't forget the hook on, and then look for the answer. Write it out. Number 9. What is the area of the region in the first quadrant bounded by left x equals y squared? It's in the first quadrant. In the graph, x equals 4y take away 3. So don't be discouraged. If y is 0, if y is 0, then x is negative 3. Let's try another point. What would happen? I need it in the first quadrant. So what would happen if x is 1, add 3, y is going to equal 1. So 1, 1 is on my graph. And I need to make them equal to each other because I got to find the limits. So I have x equals y squared. X equals 4y take away 3. So why don't I just find where the limits are, and I'm wasting my time here. So can you solve for y here? So subtract 4y, add 3. Can you factor it? So once you factor it, find the solutions and put them on your graph. And then you're going to draw a line. So where do these things happen? So whatever, I'm just going to do it for you. So at positive 3 and positive 1. Now that's on the y, right? So 1, 2, 3 on the y. And then 1 on the y. And then connect them. So 3 on the y, 1 on the y, connected. I want you to see the parabola, and it's going to be, it's going to be right subtract left. So it's going to be an integration question. What are my limits? I just found them. So from 1 to 3, and because it's sideways, it's the y value, 1 to 3. And then it's right subtract left. So you need to put in right subtract left dy. So which one is on the right? Hint. Which one is to the left? Hint. This is all in terms of y. Solve it, and then you have your answer. Number 10. And yes, you can use your calculator to calculate. A pump allows water to flow into a tank at the rate of R at t equals 3t. So this is a rate graph per minute, where t is in time in minutes when the pump was turned on. Which of the following defines a function that measures the accumulation of water in the tank during the period from 1 to x? If we are accumulating from a rate graph, that is an integration question. And what are the limits? It goes from 1 to x. What am I taking the integration from? The rate. Well, what defines the rate? That's this. I probably just gave you the answer. Let's see. Oh, and when I look at it, well, you can see. When you look at the answers, there's like this little box is like D. That should say DT. So I think it's pretty obvious which one it is, the setup, to find the accumulation of it. So pick the one that is the accumulation of it. So when you see these little box or rectangles, like here, I just see it for number 12, that's a DX. I don't know why. DX. It's a College Board silliness. DX. That's what's missing with those little rectangles. The letter D. Why? I don't know. All right. Number 11. We're almost there. Let f be that function. On what interval? And again, the little rectangle that's missing, the letter D. That's all that's missing. On what intervals is f increasing? If you're given a function, even though it's defined as an integral, how do you find if something's increasing? And the answer is you take the derivative to know if it's increasing. And then you make it equal to 0 and you draw a number line. What would happen if you took the derivative of this? This is the fundamental theorem of calculus. Take the derivative and just plug in what x is. That's it. So the derivative is just negative x squared plus 2x plus 3. You are applying the fundamental theorem of calculus. It's just a substitution question, and there's no hook on. I need you to solve this. I need you to draw a number line. And increasing means what interval is positive. Solve it, put it on a number line. If I would solve this, I would add x squared, subtract 2x, subtract 3. I would factor this, and then put the intervals on a number line. And then I would test to know which intervals are positive. And then look to see which one matches. Number 12. What is the volume of a solid generated when the region bounded by the graph y equals x squared, x equals 3, the horizontal line y equals 4, is revolved about the horizontal line y equals 4? If you're revolving, it's a circle, pi r squared. Let's graph it. Is it a disk or a washer? So can you graph y is equal to x squared? Can you graph the vertical line 3? And the horizontal line, so the graph of y equals x squared, the vertical line x equals 3, and the horizontal line y equals 4. Now, let me be accurate here so that we can get a sense of this. So y equals x squared. If we have x equals 3, this point right here would be 3 and 3 squared, which is 9. So y equals 4 is definitely below that. So let's just draw that. Y equals 4. There it is. So what's the area trapped between the three of them? So we have the vertical line, the horizontal line, and the curve. Do you see this little area in here? I'm going to shade in. Do you see that area there? That's the line, and the curve. And we're going to revolve it around that line, y equals 4. Do you notice the area hugs y equals 4? All the way through. This is a disk as you revolve around. So there's only one radius. So if there's only one radius, what are the bounds to begin with? So we have one bound at 3. That's the upper bound. What's the lower bound right here where it hits? So if I let 4 equal x squared, where does that 4 hit the parabola? Solve it, and you can see it's when x equals 2. So from 2 to 3, and then what represents the radius if you revolve it around a horizontal line is the top, subtract the bottom. So what is on top and what's underneath it? So it's the parabola, subtract 4. So can you do that? So again, if I set this up, it's going to be top, subtract bottom, and then make sure you square it, dx, right? That's the radius squared. So think what's on top, what's on the bottom. So the bottom is y equals 4, x squared above it. Put it all together, make sure it's all squared, and you're done. Look for the answer matches. Number 13. In number 13, make sure when you see a rectangle, it's the letter D that's missing. Let M be the region in the first quadrant bounded by the graph y equals 3x and y equals x squared. Which of the following gives the volume of a solid generated when the region is revolved about the vertical line, -3? So if it's a vertical line, everything is going to be in terms of y. So I need to get a sketch of this to begin with. So y equals 3x. So let's draw that line. Y equals 3x. Draw that line. And then x squared. So let's draw x squared as well. So what's the region there that's trapped between the parabola and the line? And we're revolving it around the line x equals -3, which is over here somewhere. So that's the line of revolution to the left here. So we're taking this area, revolving it around that line. There's a gap, so you can tell it's a washer. 2 circles. So first of all, what are my limits? So I need to, first of all, you can make it equal to each other, but it has to be the y's. So I need to write down divide by 3, that x equals y divided by 3. And the second one, x equals the square root of y. So take the square root of both sides so that both of these are in terms of y. Then you need to make them equal to each other. And you have to solve that. So if I square both sides and multiply by 9, and if I subtract 9y, what would happen if I factor it? What would my limits be? So y by itself, y subtract 9, what would be my limits here? And you can tell all the limits are the same. So it is 0 to 9. And then to revolve it, what's going to represent the big radius? So from the line of revolution all the way through the area to the far right. So what's on the far right? Subtract -4. And then the small radius from the line of revolution to the front of the area. So again, right, subtract left. For the small radius, what's on the right? Subtract -4. So look at the setup and see which one matches correctly. And make sure that it has this setup when you're doing it. So you can already cross out some bad answers, you know? All right. 14. Let R be the region bounded above by the graph y equals 1 minus x squared. That's the above one. And below by x squared minus 1, as shaded in the figure below from -1 to 1. What is the volume of that solid generated when the region is revolved around the line y equals 3? So that would be way up here. So if you take that and revolve it around y equals 3, do you know what the small radius would be? And do you know what the big radius would be all the way down? So again, this is the small radius. This is the big radius. It's going to be of this form, where it's pi -1 to +1, and it's the big radius subtract the small radius dx. And you need to know the big radius would be, this is what, 3 again. So it's going to be 3 subtract, what's this at the bottom? And the small radius is going to be 3 subtract this one. Put it in all together, set it up for yourself, and then get the answer. You can use a calculator to help you out if you need to. All right, last question, number 15. The base of a solid is the region in the first quadrant bounded by y equals 2 subtract x squared and the x-axis for the solid. Each cross-section perpendicular to the x-axis is a square. What's the volume of the solid? So I'm going to factor this and recognize that the two x-intercepts, which will be important to me, are 0 and 2. And then when you graph this, you're just looking at the first quadrant from 0 to 2. So how do you find the volume of that? So first of all, it's going to go from 0 to 2. The cross sections are squares. So the formula is going to look like this. And we know the formula for a square is b squared. No pi involved. It's a square. So what represents one base here of the square? So top subtract bottom. Now the bottom is 0. So it's just what the curve is. So our base at any moment from 0 to 2 could be found by using the formula 2x subtract x squared. So we're going to plug that in to the formula, right? Use your calculator, find the answer, and get a great grade. All right, there's your support for the AP Classroom assignment. I hope that helped. And make sure you take a picture of your work, submit it. Make sure you submit those results in AP Classroom. That's the second part. And I hope you get an A on this. I know you will. Mr. G Math, over and out.